At question number 4. In question 4, you've been assessed in how to find the nth term of a geometric sequence. Okay? The question reads, when a ball bounces, the height of consecutive bounces is a geometric sequence. The height of the first bounce is 121 centimeters, and the height of the third bounce is 64 centimeters. To the nearest centimeter, what is the height of the fifth bounce? Okay, so what do we have here? We have a geometric sequence. Let's go ahead and write it down. We have 121 is the first value. Second value is not known. The third value is 64. And then the fourth value is unknown. We're asked to find the fifth value. Okay, so let's assign them variables. A1 represents the first term, A2 the second term, A3 is the third term, A4 is the fourth term, A5 is the fifth term. Alrighty, so just remember that the index represents the term. To solve this problem, we need to remember our formula for the nth term of a geometric series. So nth term of a geometric sequence. Alright, so the formula for the nth term of a geometric sequence, an is given by a1 times the common ratio raised to the n minus 1. Alrighty, so that's the formula for the nth term of the geometric sequence. Now, with this formula, if you're given any two components, you can find the third one. Okay, so for example, if you're given a particular term, the first term, you can find the common ratio. If you're given the common ratio in the first term, you can find the third term. Alright? And also, yeah, so that's that. In this particular case, we are going to be using this formula twice. Alright, because we're asked to find the fifth term. What we're going to do first is we're going to use the terms that we're given, the first and the third terms, to find the common ratio. And then after we find a common ratio, we use the formula again to find the fifth term. Okay, so step 1 is to find R. What is R? The common ratio. So, we need just one unknown in the formula. The formula is an equals a1 r to the n minus 1. Okay, let's write down what we know and what we need. We know that for n equals 3, and let's say n equals 3 because we're working with the third term here. And then a1, the first term is 121. The third term, an, is going to be a3. a3 is 64. And the common ratio is what we are looking for. Alright, so we plug all this into the equation that we have right here, and then we can determine what the common ratio is. Alright, so plug it into the equation. What do we have? So, plug into the equation, we have an, which is a364, equals a1, the first term, 121, times the common ratio, r, raised to the n minus 1. So n is 3, so that's going to be 3 minus 1. Alright, so 64 is equal to 121 raised to r times r raised to the second power. Now we're going to divide both sides by 121, 121. And what does that yield? We have r squared is equal to 64 over 121. Let's write that again. 64 over 121. Okay, r squared equals 64 over 121. So what is r going to be? To get r by itself, we're simply going to take the square root. Okay, so to take the square root, root this, root that, numerator and denominator. And this basically helps us to see that the common ratio r is 8 over 11. Perfect. Now that we have the common ratio, we can now move on to the second step, which is to find the fifth term using that common ratio. Okay, So now what we're going to do, our goal is to find A5, the fifth term. Okay, let's do it. So in this new situation here, since we're working with the fifth term, A1 is still the same, 121. N is the number of terms we're dealing with, which is 5. The common ratio is what we just found, which is 8 over 11. And A5 is what we are looking for. Okay? Alright, so what we're going to do is we're going to plug these into the equation, the formula. And we have A5, what we're looking for. You know what? Let's write the formula again first so we don't mess this up. AN is equal to A1 times R to the n minus 1. Alright, so A5 is equal to A1, which is 121, times the common ratio, 8 over 11, raised to the n minus 1 is 5 minus 1. Okay, so we're going to use our calculators for this since we're asked to find the approximate value. So 121 times 8 over 11 raised to the fourth power. Okay, let's plug that into our calculator and we're going to round it to the nearest centimeter or the first decimal to the ones place. Alright, I'm going to be using the TI-84 to enter this expression. So we have 121 times 8 divided by 11, 8 divided by 11 raised to the fourth power. Enter 33.8512397. If we round it to the nearest centimeter, it's going to be 34. Okay, because we're going to round up because the number in the tenths place is 5 or greater, so you round up. Answer to question 4 is option number 2. So this is basically how you use the nth term formula of a geometric sequence to find the common ratio, and then use that common ratio on the first term to generate another term of the sequence. Alright, let's take a look at question number